talking with the or with the I mean the procurement guys that bring this number of pieces of timber. So the contractor will not know that you've not allowed for waste. So you'll realize that materials are less because waste came up, and then you've lost a given a considerable quantity of material, and then you can't finish the work. So it's you in trouble now. Yes.
So e-waste inakwanga 3 ama 5%.
So e-waste inakwanga 3 ama 5%.
You can do it's not normally depending on the quantity. You know, the percentage will reflect on the, let me say, the resultant quantity of material that you have. So for example, if you have like 1,000 feet and then you allow 3%, and then somebody also has like 10,000 feet, then you allow 3%, you realize that when you are constant in your allowance for waste, when the number rises, when the figure rises, then you will be having a larger quantity of allowance, so that can blot your quantities or your materials to be ordered for no reason. So I would advise that when the quantity is higher, in your assessment you see it's higher, then you allow a smaller percentage for waste, so that you don't bring in on site material that is in excess, or whatever is going to make you guys run into losses because you've ordered materials that are much. Yeah, so if it's considerable, you can leave, you can allow like 3%. So you just try, when you allow for 3%, what is that given, what does that translate into in real figures? Then you see that now this is reasonable enough. It's just a matter of reasoning with the actual figures and precisely what does it read in terms of cost. Okay. Yeah, because you understand your role. Of course, you need to make sure that your cost there, the cost that is going to be used for those given works, is as controlled, or say low as possible as it can be. Of course, with a better quality of works. Yes.
Easy balls. Is it 12 millimeter high density diameter high density balls?
Balls. Okay, from your BQ, what does it read? Number, right?
Number 17. Number.
Yes. 17. Now, being that now there is I'm not sure whether you have the structural drawings, but even if you do, such are normally those minute, or let me say, those are details which are not easy to be noticed until you have that structural drawing which is showing you that this is how the bolting is going to be. This is how the bolting is going to be used on these given structural steel roof members. So if you don't have that, it cannot be easy to tell that now at given interval of, let me say, 1 meter, or let me say 600 millimeters. It's not easy to tell, but does the description tell you that they were put in given interval? Yeah, so if if they're just defined and then you've been told that, so normally you can give an allowance for them. If you're not sure, you can give an allowance for them. That is now when you're making your own BQ. So just give an allowance for bolts. But if they are provided, then which is the safest way, when they are provided for you in the details, the structural engineer's details, then you are able to count the number of pieces of those bolts, and then you number them, and of course you await to price them depending on the rates, labor that will be used, and all other components that will determine your rate. Yes. All right. So we've covered those parts that. Yeah, of course, items like a roof covering, you understand, is in square meters. Yeah, but then if in case there is any doubt in those given parts, then we just do it. We'll just revisit.
Yeah.
Yes, just revisit
Yeah.
such.
Mm.
Yeah, plus of course you will do your research, different types of roofs, and yeah, depending on the choice of the client, and of course the advice with the architect and the design, they are varying. There are so many of them. Yeah, so I would like to just take a
Yes,
yeah, anyway, let's cover these three.
Yeah.
So let's start with the, for example, let's just do mass concrete, and then now a VRC. VRC also we do just one class, and then we do hardcore, you said, and then we should be done with it. So for example, mass concrete. Mass concrete, of course, when you do your BQ, you'll be having square meters. Just a minute. Yeah, so when you have your square meters, that is now what you need to convert to. You need to now calculate those given constituents that we've talked about. Cement, sand, ballast. That is what you now need to calculate from in reference to the area that you've already calculated. So for example, an area of 146 square meters, you will multiply by the 0.05. Yeah, 0.05 is now 50 millimeters thick mass concrete for the blinding. Yes, then you multiply by 3 number. Yeah, so in this. Yeah, you are getting me. Yes, so you calculate the volume. So area times the thickness. Yes, area times the thickness. Then three bags of cement. By rule of thumb, or by experience, for those that have been on the field, that you'll also join, or you are also part of, depending on your experience, three number of bags makes a cubic meter of mass concrete. So you take the 3 times the volume. Yes, 3 bags of cement. So you convert into volume. So every cubic meter should be equivalent to 3 bags of cement. Yes, so you will get the number of bags. Yeah, that is mass concrete. Class 1 to 4 to 8. Yes. Then now, once you have the bags of cement, it's easier to get the bags of the number of tons of sand. Yes, in this manner. Just a moment. No, so for sand, what you'll do, you'll also still just get the volume. This is volume times 1.5. 1.5 is now the conversion factor of tons of sand for every cubic meter of mass concrete is 1.5.
cubic meter.
Yes. So for every cubic meter, you should have like about 1.5 tons of sand. Yes. So that gives you the number of tons of sand. So if you want to order in terms of lorries, depending on the capacity also of your lorry, for instance here we'll use like 18 ton lorry. So for the 18 ton lorry, now you divide the total tons divide by 18, then you get the number of trips of lorries that